Alright, so in this video we're going to look at exponential growth and exponential decay. So let's say I have a function like f of x equals 100 times 1.15 raised to the x power. Okay, we actually saw this function in problem 1b, and for the 1.15 we said, well, we're applying a 15% increase from month to month, so we're repeatedly multiplying by 115%. Okay, now if I break down the 1.15 as 1 plus 0.15, okay, just to highlight the fact that you're seeing that 15% increase on top of the 100% of the original amount. Okay, we're going to call that 15% the growth factor. Okay, so more generally, if you have an exponential function where the base is 1 plus r, so you want to think 100% plus some additional percent. Okay, we're going to call that r percent value the growth factor. Okay, so on the other hand, if I had something like 2.54 times 0.85 raised to the x power, okay, now I can write 0.85 as 1 minus 0.15. So I'm thinking 100% and then take off 15%. Okay, so now this is really going to correspond to what we'll call exponential decay, and this minus 15% is what we'll call the decline factor. Okay, and so more generally, if you have 1 minus r, so 100% minus some r percent, then that decline factor is minus r percent. All right, so now let's look at some examples here. This is question 5 on the worksheet here. So we're asked to identify the base and the growth or decline factor as a percentage for each of these exponential functions. So part A, our base would be 1.25. And so in this case, growth factor, we're thinking I have my 100%, the 1 plus 0.25, 0.25, which is 25%. So my growth factor there would be 25% from output to output. Okay, for B, we have 0.894 times 0.55 raised to the t power. So our base is 0.55. And here I can do 1 minus 0.45. So I'm thinking 100% minus 45%. So we'd write this as minus 45%. This would be our decline factor. All right, moving on to C. H of x is 5 times 2 to the x power. So there the base is 2. And here you can think of 2 as just 1 plus 1. So I'm taking 100% of the original amount, and then I'm adding on, well, 100% of that original amount. So here the growth factor would be 100%. Okay. If you double something, okay, you're really applying a 100% increase to that amount. That's what this says. Okay. For D, we have 3 times 2.94 raised to the t power. So our base is 2.94. And then we can think of the 2.94 as 1 plus 1.94. So I'm taking 100% plus 194%. So our growth factor now would be 194%. All right, and then for the last one here, h of x is 5/3 raised to the x power. So our base is 5/3, and 5/3 is 1 plus, well, 2/3. And 2/3, if I'm thinking in terms of decimals, it's 0.6 repeated. So it's 0.6 repeated. So as a percentage, this is going to be about 66.7% roughly. Okay, so that would be a growth factor there as well. All right, that's going to do it.